Welcome to Algebra 2, Unit 9, Algebra 2, Semester 2, Unit 9, Section 3.3. Today I just want to go over graphing linear inequalities. And I gave you some notes up here to go through. You can go through those on your own. It's a little bit of a repeat of yesterday, reminding you how to graph, but then also talking about the inequalities. I'm going to go ahead and graph with you. You can read that later and highlight information, ask me questions from it if you're not clear on it. So the first thing we do in graphing is get the y alone. Look at what I did for you. I gave you y alone. So on this first one, it's going to be less than or equal to, my slope is 3 over 1x and negative 2 is my y-intercept. So I go down to negative 2, put a point, just like we did with the linear graphing yesterday. And now I say, well, I'm going to rise 3 and run 1 to the right, because it's positive. So from that point, I rise 1, 2, 3, and 1 to the right. Now, the last thing that I have to ask myself, how do I show that it's less than or equal to? Well, if it can be equal to it, it would make sense because I graphed with an equal sign a solid line. Then I can graph this with a solid line. But how do I show that it's less than? Well, I come to the y-axis and I say, which number is less than that negative 2? Is it negative 3 or positive 1? Because it's negative 3, I shade to the side of negative 3. Next equation, I have a y-intercept of 4. So I come to the graph to positive 4, 1, 2, 3, 4. And now I have a slope of negative 1 over 1, or just a negative slope of 1 over 1. So from that point I rise 1, run 1 to the left. Now I cannot do a solid line because it doesn't show that it can be equal. So I can't just run a solid line there. My only option is to say, well, here's where the line is, but it can't be equal to it. So we just dash the line, showing it can't be on that line. Now, I look at the sign that says y is greater than. In other words, sorry about that, y is greater than. In other words, the shading should be on the greater than side of this line. So at positive 4, which is greater, 5 or 3? 5 is greater than 4, so I shade to that side of the line. Now, do you see where this is double hatched right there? Both lines are shading it. I just ask you to kind of shade it in a little bit darker. That shows me that you see the solution. Okay, next graph. We need to get the y by itself. In order to do that in this first one, we'd subtract x from each side, so we end up with y is greater than negative 1x minus 3. It's a negative 1 over 1. Go ahead and turn off the video and graph that, and then turn it back on and see if you have it right. Y-intercept of negative 3. It rose 1, ran 1 to the left this time. And we cannot be equal to, so we have to do the dashed line. Along with the dashed line, we say, well, which is greater than 2 or negative 4? Negative 2 or negative 4? Negative 2 is greater. Greater is going up on that line. So we shade that way. Now the next one, we need to add 6 to each side to get that y alone. Add 6x actually. And we can write it over 1. There's always a 1 under a whole number. Okay, so we go to positive 1. From there, we rise 6. 1, 2, 3, 4, 5, 6, and run 1 to the right. That's an approximation. So as I come down, make sure that when I hit the 6th box from that y-intercept down here, I want to make sure that I'm exactly at the 1, which I am. That one has to be dashed as well because it cannot be equal to it. And now from this point at positive 1, it needs to be less than. Would 0 be less or would 2 be less? Hopefully you said 0. So we shade to that side. Darken in this area where there's double shading. Okay? The last inequality, I wanted to get some other shapes other than just linear on here. This is absolute value. Hopefully you remember absolute value is a V shape. It's got a stretch of 2. And what does this one do? Hopefully you said that it makes it go 1 to the left. So we take our parent graph, we bring it over 1 to the left, put our vertex, we stretch it up to 2, and we see that we have our V shape, which I don't know why I didn't use a ruler on that side. I apologize. There's our V shape. Now, it's greater than this. Well, it's kind of hard to tell. Well, which way is greater or less or whichever? You could go back to your y-axis, but I wanted to show you one other option when you're shading. Is you could choose the point 0, 0. If you plug that in and it comes out true, then you know that the shading's that way because it's part of the solution. So we plug in 0 for y is greater than or equal to 2, parentheses 0 plus 1 absolute value. Absolute value of 1 is 1. 1 times 2 is 2. Is 2 less than 0? No, so we don't shade out here by the origin. Instead, we shade in here. Okay, the last one is a linear function that we go ahead and graph. It crosses at positive 1. It rises 1, runs 1. So it goes like that, and it cannot be equal to it, so it has to be a dashed line. So those two really only share 1 point right there, and that's it. I'll erase my mark on the origin from when we were trying to figure out how to shade that one. That's the end of the lesson. Thank you very much. See you tomorrow in class.